Okay, what's up and welcome back. This is the Prokon Geek and welcome back to the Prokon Geek Slab Detailing 101, getting preview with slab detailing in short and concise lessons. And in today's video, we're going to be focusing on the curtailment of steel. So without wasting too much time, let's get right into the video. Okay, so first things first, if this is your first time, please click the subscribe button and also remember to click the notifications bell. Also leave a like and a comment at the end of this video and just tell me if you enjoyed it or if you did not. Anyways, once you are done doing all those things, let's get started or dive into the content of this video. Okay, so the content of today's video is going to be on curtailment of steel. What is curtailment and why is it important? So I'm just going to be giving you the definition in my terms or in my own paraphrased way that I got to understand curtailment, right? But before we actually do that, I just want us to look at the slab that I have on the screen right now, or the drawing that I have on the screen with me. It's a 6 meter by 3 meter slab. As you can see, this is 3, 3, and this is 3. So we have a double span and a single span there. 3 by 3 adds up to 6, and 3 is just 3. So it's a 6 meter by 3 meter slab. And this is what I've titled it. This is how non-curtailers would handle detailing. By non-curtailers, what I'm just trying to say is, in a world where you would not curtail steel, this is how you would present your bars. As you can see, presented by the green lines or represented by the green lines. Now, as you will see, the shape codes used when you do not do curtailment are very different from the shape codes that I showed you in the previous video. And there's a reason why, because curtailment takes into consideration a lot of things which non-curtailment does not. Now, why is it important, or what is curtailment exactly? So to bring out curtailment exactly, what you need to understand is maybe the design of a beam or a slab. Now, most people will know that when you start designing any concrete elements, you design for the moment that occurs at the midspan. Now, most people will know under normal loadings or most normal loadings in the real world, the maximum moment will occur at the midspan of your slab or your beam. So that means the maximum steel you need to provide will mostly cater for the moment that is at the midspan. But as you move away from the midspan, the moment actually reduces. So the area of steel that you need at the midspan is different from the area of steel that you need at the externals or at the supports. And when it's a continuous slab or a continuous beam, you will find that mostly at the supports, you might actually virtually need no steel at all, but they need steel at the top of your slab or the top of your beam that is at the support. So in other words, in theory and in practice, the steel that you get when you design, or that you get from the design calculations, is just mostly needed at the midspan and at the top of your supports. And in some areas of your slab, you actually do not need any steel. So this becomes important, especially when you go to big projects, because now let me just put out the reasons for you. Yes, this is how non-curtailers would handle detailing. But one thing you need to understand is that steel is expensive, because as the diameter of your steel bars increases and also as the length of the steel that you buy increases, then your cost per project or your total cost also increases. And then number two, sometimes you only have short length bars, especially in developing countries. Now, you need to understand something. Steel comes in certain lengths. In most cases, it comes in 6 meter lengths, 12 meter lengths, or 13 meter lengths. So in cases where you have a 7 meter length bar in a situation where you don't have 12 meter or 13 meter, or where you need to provide steel over an area of 20 meters, you see that is not possible using one bar. So therefore you will need to join two bars, and the joining and the way that you do that is what is covered in curtailment. So in essence, curtailment is providing, right, or is actually providing 100% steel where it's most required, but then providing less than 100% steel where it is not required. In essence, you're just cutting your bars when they reach to a certain stage, because at that stage the steel is not required. Or what you're doing is you're using these rules to provide lap lengths that allow you to provide bars which are more than the provided or the sold lengths in shops. So let me show you an example what you would prefer to do if you were going to be curtailing your bars. Now I know the previous drawing looks simpler when compared to the curtail drawing. That is because curtailment in essence is much more complicated because there's so many rules as opposed to when you're just doing the normal detailing. But one way to point out why it is important, let's just look at the top steel. Now if we go to the top steel, in this case where you have bar mark 005, if I just EI, you will find that this bar is 6,200 for the leg C, then 200 is 700 and 200 is 700. So the total length of this, let's just check that in the bending schedule. No, it's not updated. Just go to the window, show and hide bending schedule. And if we go to bar mark 005, right, the total length is 7 meters 900 given there as I'm showing you. Now just imagine you're in a country where the maximum bar size you use is 6 meters. So this bar is not feasible, and once this steel is shipped out to site, it no longer makes any sense, and your steel fixer will not be able to provide what you wanted on site. So in simple words, you would have made a huge, most engineers in the field will tell you it's a huge F up. That is what most people actually say. So you would have made a huge F up because you did not consider that you could have short length bars. But now in the situation below, look at this. What you did is you understand that the steel is needed at the top of the supports. So you provide a U-bar. In this case, it's now bar 00D, right, to cater for the steel. And in the middle, you know that no steel is mostly required when it's at the top. That's when you now introduce laces. And instead of using 12 millimeter diameter bars, you are now using 10 millimeter diameter bars as seen by 7Y10's bar mark 00F. So in other words, you have now shifted the diameter down and you've also reduced the length of the bar, so it's now less expensive as compared to the original design. Now some of you may be asking, why go through all this complicated step of curtailing bars? Let me just try and bring an analogy of what curtailment is like. Well, in small projects, as many people will argue with you, or you find people will tell you that curtailment is not necessary, it's too complicated for small projects. I agree with them, because for small projects you can get away with it. The cost, the amount of money that you save on small projects, it's very small. But one thing I need to, when it comes to big projects, curtailment becomes very important. One analogy that I need to give you is that imagine you're 400 pounds overweight. Now what we would do is a small project, curtailment on a small project, we're going to equate that to going on a diet for 2 weeks, and curtailment on a huge project, we're going to equate that to going on a diet for a full year or 2 years. Now going on a diet per year results in you losing half a pound every day. So if you go on a diet for 2 weeks and you lose half a pound, after 2 weeks you lose 7 pounds, and 400 minus 393 pounds, no, 400 minus 7 pounds equal 393 pounds, and 393 pounds is still a lot, you're still overweight. But when you go on a diet for a year and you lose half a pound every day, let's just calculate how much that comes out to. So you're going to say 365 multiplied by 0.5, that's 182.5. So we're just going to round it to 183. Now when you go 400 subtract 183, you see that you are in the range of 217 pounds. And if you do that for another, let's just say half a year, and then you subtract 90, you now weigh 127 pounds. Well, now that's a little bit too much. I think 217 pounds is a nice weight, especially when you now have muscle. This is what we're talking, this is the average buff guy, he's around 200 pounds. So what we're just saying is, you see, when you diet for a small period, it's not as useful as when you diet for a longer period. So small projects may not really benefit from curtailing, but big projects will definitely benefit from curtailment. So right now it's still a bit confusing as to how you actually curtail or do some of those things. So what we'll do is, as I said, we're going to try and simplify it in the next chapter, where we will now be looking at the rules for curtailment. So this will be based on a bunch of rules they wrote down in the paragraphs, but I'm going to explain them to you and simplify them so that you get to understand. So hopefully, I hope this video was clear. If it was not, I'll just leave some notes on curtailment so that you're able to understand where it comes from as well. But thank you very much for tuning in. If this was your first time, please subscribe. Also, please leave a like on the video to help me with the algorithm. Also leave a comment, and until the next time, or until the next video rather, I'll see you and peace out.